Hello guys, welcome to our classroom. Today we'll be doing the number system. So I'll be starting with, oh, by the way, this is my first video on YouTube. So grade 10 mathematics. So most of the time I will be using this study guide, the maths handbook and study guide. For me, this is the best. This is just the best. Shout out to Kevin Smith for what's this book. Okay, now let us look at this topic. By the way, I haven't introduced myself. The channel name is Back to Basics because we are going back to basics here. Reason why is I've taught grade 12 and I've seen that most of my learners were missing basics. Like the teacher grade 12, they were missing basics to grade 10 and they are very important. So that is the reason for this channel. We are going back to basics. So today, and then whatever we'll be learning in this YouTube channel, everything will be according to the ATP, to the annual teaching plan. So whatever we'll be doing here is something you'll be doing classing. So this is just to supplement your lessons because sometimes they might not be enough. So this is just to supplement. These are not to replace the class school of school. YouTube channel. Yeah. So yeah, guys, this is just to supplement your learning. So let's get right into it. Okay guys, let's continue. So I'm going to show you a diagram that is going to help you grasp this content easily. So we start with natural numbers. So natural numbers are denoted by this sign. So natural numbers are numbers that start from 1 going upwards until infinity. So 1 being a positive number, when you go up, it means you continue with other positive numbers. 1, 2, 3, 4, up until infinity. This is the sign for infinity. Yes. So up until infinity. So this is our natural numbers. And then we come to whole numbers. Now whole numbers begin from 0 going to the positive numbers. Whole numbers. Now whole numbers are denoted by this sign. It's an N and then 0 class. This is a 0, it's not an O, it's a 0. 0. So this is how you denote your whole numbers. The natural numbers is just N, and then whole numbers is N and a 0 to show where do we begin? We begin from 0. Okay, so we said 0, and then 1, and then 2, and then 3, up until positive infinity. Positive infinity. Because remember, starting from 0, going to the positive numbers, it means you'll end positive infinity. Now, infinity means basically there's no end. You are just continuing until. Then let's go to the next one. So this diagram is just to help you understand when we say whole numbers. You see, kamohara, secondly, whole numbers, what do we have? we have natural numbers, because the numbers that are in the natural number system, they also exist in the whole number system. You see, that is why the circular natural numbers is inside whole numbers. Ne? I hope you get it. Okay, now let's move to integers. Ne? Integers. Now, I hope the way I'm going to explain it is not going to confuse you guys. Ne? So integers are those that we extend whole numbers to go to the negative number system. Ne? We extend whole numbers, get to the whole number. So we extend them to go to the negative numbers. Now remember, on your number line, negative numbers are on your left hand side after 0. Okay, so it means if we say we extend our whole numbers, get to the whole number 2, 3, and then we go to the left, and from a 0, when you go to the left, that is where you introduce now your negative numbers. Ne? So what do we have before 0? We have negative 1, and then before a negative 1 comes what? Negative 2. Before negative 2 comes what? A negative 3, up until negative infinity. Now these 3 dots means we are continuing. Okay? So we continue to negative infinity. So you can say you begin from negative infinity, you begin from the smallest number, you end with the biggest number. Okay? So it's like you begin from negative infinity and then you end, positive infinity. These are our integers, ne? And integers are denoted by a letter Z, capital letter Z. Like you can put bracketing the notions. Ne? Now we continue with our diagram, ne? Our number system diagram. Now let's close. Okay. Now you see now your number system diagram. It has natural numbers which are inside circular and the whole numbers, ne? And then integers. Inside this circular integers, we have what? We have whole numbers and natural numbers, meaning that integers, you will find whole numbers. Same thing. Got the integer, you will also find what? Natural numbers. 1, 2, 3. That is what this diagram means, ne? Okay, we go to the third one, which is rational numbers. Rational numbers. Now, rational numbers are numbers that can be written as fractions, ne? Fractions, you know a fraction in a numerator and denominator, ne? So, we can denote rational numbers by letter Q, capital letter Q. We denote rational numbers as Q. Ne? Okay, so now you know a fraction has a numerator and a denominator. Okay? So, and then one condition in mathematics that you must know is that your denominator must never be 0. Ne? So whatever fraction you have, let's say we have 3 over 4. That's a fraction. Okay? 3 numerator, 4 denominator. So this is your rational number. Ne? This is your rational number. And then another example is it can be a decimal that is recurring. Recurring means what? Okay, 0,3, ne? It's a decimal number here, and then 3 dot code. This dot is the one that shows you this number, the 3 is recurring. What does it mean? If it's 0,3, it's the same as 0,3333 until. So I want to This 3 is recurring level. That's what it means. Ne? Another thing that defines a rational number, it's a decimal that terminates, meaning it's a decimal that ends. For example, 0.75. You see, there's an end. If a logo 75, meaning that this decimal is terminating. Ne? Now this is our rational number system, and then irrational numbers. Ne? So, looking at this diagram, let me take this back. Okay. Yeah, okay. Now, you see all these natural numbers, whole numbers, integers, they are all under rational numbers. They're all under rational numbers. And then we move on to the last one, which is irrational numbers. So, let me do this. Irrational numbers. Irrational numbers, ne? Now, irrational numbers are numbers that cannot be written as a fraction, ne? They cannot be written as a fraction like rational numbers, so, ne? So, first thing, let me write it down. Okay. Cannot be written. Never mind my handwriting, ne? It used to be nice, but not anymore. Anyways, let's continue. Cannot be written as a fraction. Ne? Second thing is that irrational numbers do not have terminating decimals, ne? Non-terminating decimals, meaning that if you have a non-terminating decimal, let's say 0, let me test this one. Guys, we have our calculator here, 11. We have our calculator. Oh, sorry. So let's try pi, ne? Now pi is also an irrational number. So we have 3. The value of pi came 3,14159,265. You see, I'm writing. 11. So check the difference between this decimal and this decimal. You see, 0.75 terminates. 3,14159,265,359. It's a non-terminating decimal. So that is how you identify it as an irrational number, ne? Okay, and then the third, the last one is that irrational numbers do not have recurring decimals, ne? Remember, a recurring decimal is like this one, whereby you have a dot on top of a decimal, showing that decimal repeats. It recurs, ne? Okay. And then another example of an irrational number, we said it's pi, okay? And then another example of an irrational number is called a surd. The number whereby when you put it under a square root, it does not give you a whole number. It does not give you, it's either it does not give you a whole number or it remains like that. I get the square root of 2. That one, key, it gives you a non-terminating decimal. It gives you a non-terminating decimal, you see? Or it appears as it is. Like so that's another irrational number. Another example of an irrational number, we have the cubed root of 9. We have the cubed root of 9. Let's see. Remember we said it is not going to give you a whole number as an answer. Number 1. Ne? Number 2, it's going to appear, if you punch it inside the calculator, it's going to appear exactly how you pressed it. Like it gives you a non-terminating decimal. Remember, which is one of the conditions for an irrational number. And then again, see when you burn the answer, it comes out exactly as you punched it in. It's not simplifiable. Like so getting 3 to the power 2 9, guys, we all know. Okay, and then you see it's like the same number you punch it into the calculator. Né? Now look at this. Irrational numbers are not a part of this system. Like why is it so? Both of them, rational numbers and irrational numbers, both of them, when you put them under one thing, they are called real numbers. Real numbers. Eh? Meaning that when we now talk about real numbers, it means now you consider all of the numbers that are in a number system. Ne? So, to conclude this lesson, guys, I hope you have learned a lot. Oh, sorry, guys. Real numbers are denoted by a capital letter R. Ne? So, yeah, we are done. And I hope you enjoyed this lesson, guys. If you have any questions, you can comment. If you have any questions, if you have anything to add, yeah, you can just drop your comments in the comment section, and then yeah, we'll meet. Thank you, guys. Bye. And please, guys, don't think Otlapasa maths by just praying. Ne? Make sure you put in the work, because maths it's only driving. You cannot be perfect unless you do it. Ne? Maths it's only driving. You can't be perfect unless you drive. So another thing is confidence, guys. Make sure that you are confident even when you see, okay, this one is challenging me. Bring in the confidence and you will see wonders. Right? See you guys. Love you. Bye. Okay, now we are done with the number system. Ne? So all you can do is copy this table, or if you have the study guide, you can use it to fill in this table. Mara, you can copy the table and then and then complete. Ne? You see they say copy the following table by placing an X in the correct column. Ne? What you do is you look at this number. It's 4 over 5. Okay. Now you say, okay, this 4 over 5, is it a natural number? Is it a real number? Is it an integer? Is it a rational number? Is it an irrational number? Remember this to note these symbols, they mean something. Okay, this N is for natural number. Remember, this N with the 0 is for whole numbers. This Z is for integers. Q is for rational numbers. Q with the stroke is for irrational numbers. Ne? So what you do is you look at the number that is given. You look at the number that is given there, and then you tick. If it's a natural number, you place your X there. If it's a rational number, you place your X there. Ne? Now remember, a number can be both. Ne? Remember, a number can be a natural number, can be a whole number at the same time. Okay? Why am I saying that? Remember this diagram. 1, 2, 3 is a natural number. but it's also a whole number. You see? So a number can be more than 1. It can be 2. Can even be 3. That one. So, okay. So that's what you're going to do for this as your exercise now. Making sure that you grasp the concept.
Thank you guys for watching. Don't forget to like, comment, and subscribe. And please share the videos with your friends. Make sure everyone is making it, guys. Don't be selfish. Thank you guys. Bye. See you on the next one.